today. Now, keep in mind that although we're talking about division properties of exponents today, all of those other rules are still in effect. So, the division properties of exponents are super similar to actually some of the other rules that we've learned, but kind of in the opposite way. Okay, so let me show you what I mean by that. So, the first rule, we're going to learn two of them today. The first one is dividing powers with the same base. So we've already multiplied powers with the same base. And watch how cool math is right here, okay? When we're multiplying powers with the same base, like if I have x squared times x cubed, x squared times x cubed, what do I do with these exponents? You add them, right? Because there's two of them, there's three of them. So guess what happens when you divide powers with the same base? You subtract them! Multiply, add, divide, subtract. I mean, I know, math is just so cool. Amazing. Okay, so the reason why, once again, we need to understand the why. The reason why we subtract the exponents, if I have something that says a to the 6th over a squared, the rule says we're going to subtract the exponents, so I would take 6 minus 2 and I would get a to the 4th. The reason why we subtract the exponents, let's expand it out. A to the 6th is a times a times a times a times a times a. And a squared is a times a. Now what happens with fractions is we can cancel out common factors. So what happens here, that a in the numerator cancels out with that a in the denominator. And that a in the numerator cancels out with that a in the denominator. Now, all the a's in my denominator are gone. So the 2 in the denominator canceled out. 2 of the 6 canceled out. So out of the 6, 2 of them are gone. 6 minus 2. That's why we subtract the exponents here. Okay? Now, the other rule is going to be very similar to the power of a product. So remember the rule we learned yesterday. If I have xy squared, it means that you're going to square everything inside of those parentheses. You're going to take x squared and y squared. What happens with the power of a quotient? Basically the same thing. Everything gets the exponent. So you have a over b to the m. You're going to take everything in the numerator to the nth power and everything in the denominator to the nth power. Now, kind of like we talked about yesterday, where this gets tricky and where students forget things are the numbers. So, here's the why. When you have 2x over 5 to the third power, the rule says we're going to take 2 to the third power, x to the third power, and 5 to the third power, which would be 8x cubed over 125. Now the y, once again, if we were to expand this out, 2x over 5 cubed means 2x over 5 times 2x over 5 times 2x over 5. And if you expand it out and then crunch it back up, guess what? We have 2 times 2 times 2, 2 cubed. X times x times x, x cubed. Over 5 times 5 times 5, 5 cubed. That's why everything gets the exponent. Questions? All right, last section here. This should be page 73, section 7.4, and it's going to be division properties of exponents. All right, number 1. Number 1 says 3 to the 5th over 3 squared. Now we have our rule. We are dividing powers that have the same base. But for the first couple, I'd like to just remind you why the rule works, because that's going to be really helpful. 3 to the 5th is 3 times 3 times 3 times 3 times 3. There's 5 3's being multiplied in the numerator. 3 squared in the denominator is 3 times 3. If you have 3's in the numerator and 3's in the denominator, they're going to cancel out, right? So you have 1 3 cancels out, another 3 cancels out, all of them are gone in the denominator, right? So you had 5 in the numerator. 2 of them canceled out. That's why you take 5 minus the 2. You'd have 3 cubed. Right? You'd have 3 times 3 times 3 left in your numerator. And 3 to the third power, 3 times 3 times 3 would give me 27. Okay, number 2. X to the 6th, y to the 9th, over x squared, y to the 5th. Okay, once again, at least for the first couple, let's break it down. We have x to the 6th in the numerator. You have 6 x's in the numerator, you have 2 of them in the denominator. Right? These 2 in the denominator are going to cancel out with 2 of these in the numerator. So if you had 6, 2 of them cancel out, how many are left? 4. So you've got an x to the 4th in the numerator. Okay? And then you have y to the 9th over y to the 5th. Right? 5 of them are going to cancel out. When they cancel out, how many will be left? 4, right? 9 minus the 5 that canceled out, so you have a y to the 4th left. Now, what I want you guys to notice is that kind of picturing this in your head, when you have an x to the 6th over x squared, the 2 in the denominator cancel out, which means the ones that are left over are in the numerator. That's not always going to happen. Okay? If I had this switched, and if I had like x squared over x to the 6th, you'd still get x to the 4th. But where is the x to the 4th at? Aren't they down here? Right? If you had x times x over x to the 6th, lots of them, right? Those are going to cancel out, those are going to cancel out, and you still have an x to the 4th, but you see how it's in the denominator? Okay? So, keep that in mind, because you are going to subtract the exponents, but the power is going to stay where the larger exponent was. Yes?
So are you saying in a situation like that, it would be a negative 1?
It would be 1 over x to the 4th. Yeah, that x to the 4th just in the denominator. Yeah. Now, if you wanted to subtract your exponents, well, it could. Because 2 minus 6 would be x to the negative 4th, and guess what? What is x to the negative 4th? 1 over x to the 4th. That works too. I like thinking of it just where they left over at instead of even there in the denominator. Okay, let's try another one. Number 3. M to the negative 3rd over m to the negative 5th. Now, what I will tell you on these problems, there are more than one ways to approach these. I'm dividing powers at the same base, so if you really, really want to, you could just subtract your exponents. Here's where students struggle with that. If you're going to subtract your exponents, you're going to have to take negative 3 minus a negative 5. And you're going to have the minus and negative right next to each other. And what I find, most students won't do that. So what I prefer to do, I'm like a positive person, right? I like working with positive numbers. So what I prefer to do, before I subtract, before I simplify, I like dealing with positive exponents. So what I'm going to do is I'm going to make both of these positive, which means they're basically just going to flip sides of the fraction bar. So the m cubed is going to come down to the denominator, and the m to the 5th is going to go up to the numerator. Now, if you wanted to, now you could subtract your exponents, and I almost guarantee you, you'll do it correctly. If you had 5 in your numerator, 3 in your denominator, 3 of them are going to cancel out. How many are left? 2. And where are they at? On top or on bottom? They're on top. They're in the numerator, so it's just an m squared. Now, once again, if you want to subtract your exponents, you would have to take negative 3 minus a negative 5. As long as you do it correctly, negative 3 minus a negative 5 is 2. So you would still get m squared. But like I said, what I find is most students will forget to do the minus and negative. So I prefer just to work with positive exponents. Okay, let's try this. X to the 4th, y to the negative 1st, z, over x to the 4th, y to the negative 5th, z to the 8th. And once again, this is just my preference. What I'm going to do first, I'm going to fix the negative exponent. So, y to the negative 1st, y to the negative 5th. What I'm going to do first, I'm going to make those positive. So I'm going to leave everything else the same. So the x to the 4th, the x to the 4th, the z to the 8th. That part's not changing. None of those have a negative exponent. But basically what I'm going to do is just flip the y. So the y to the 5th goes to the numerator. The y to the 1st goes down to the denominator. Now we can simplify. So if we start with the x's. Now I've got an x to the 4th over an x to the 4th. How many of these are going to cancel out? All of them. Right? They're all going to cancel out. Just think about this. Okay? Anything divided by itself, 2 over 2 is what? 1. 5 over 5, 1. 1 million over 1 million, 1. X to the 4th over x to the 4th, 1, because they all cancel out. But if you wanted to apply the rule and subtract the exponents, 4 minus 4 would give you x to the 0. What is anything to the 0 power? 1. 1, right? It all ties together. Okay, so this is just going to give you 1. So what happens is all the x's, they kind of cancel out. Now you have y to the 5th over y to the 1st. How many y's are going to cancel out? Just 1. How many are left? 4. Where are they at? They're in the numerator, so I have a y to the 4th. Now with the z's, I have a z over a z to the 8th. How many z's are going to cancel out? Z over z to the 8th. How many z's can I cancel out? How many cancel out? How many would you be able to cross out? Just 1, right? Just 1. So this z is gone. How many of these are left? There's 7 of them left, but you see where they're at? See how they're down in the denominator? Right? Because the 1 in the numerator canceled out. The 8 that were in the denominator, 1 of them canceled out, but they're still down there in the denominator. So your answer is y to the 4th over z to the 7th. Okay, let's try a couple more of those. Okay, number 5. 2 squared, a to the 6th, b to the negative 3rd, over 2 to the 4th, a to the 4th, b squared. Okay, once again, what I prefer to do, I'm going to fix the negative exponents first, and then we can simplify everything all together. So actually, the only negative exponent I have here is the b. So I'm just going to leave everything else the same. 2 squared, a to the 6th, 2 to the 4th, a to the 4th, b squared. I'm not going to move any of that. It's just going to stay the same. But that b from the numerator is going to come down to the denominator, and the negative 3 becomes a positive 3. Now we can go about simplifying here. So the 2's, I have 2 squared over 2 to the 4th. How many 2's are going to cancel out? 2 are going to cancel out. How many are left? 2. Where is the 2 squared at? It's going to be in the denominator. So I've got a 2 squared in the denominator. Now let's talk about the a's. I have an a to the 6th and an a to the 4th. How many a's are going to cancel out? 4 of them, right? Because you've got 6 and 4. You can only cancel out 4, right? All of these are going to be gone. How many are left in the numerator? 2. Okay. So we've got an a squared over the numerator. Now look at the b's. See how I have a b squared and a b cubed, and they're both in the denominator? These aren't going to cancel out. Because to cancel out, they'd have to be in the numerator and the denominator. These are both in the denominator. So what you have is you have a b squared and a b cubed. How many b's do you have? You have 5, and they're all in the denominator, so you have a b to the 5th. So last thing, we wouldn't want to leave it as 2 squared. We want to say a squared over 4b to the 5th. I stand by what I said yesterday, that the more work you show, the easier they are. Okay, number 6. 36, x to the negative 2nd, y to the negative 3rd, c to the negative 7th, over 4x cubed, y to the negative 5th, c to the 4th. once again, just personal preference. Anything that has a negative exponent, I'm going to move. So the x to the negative second, y to the negative third, c to the negative second, y to the negative fifth. I'm going to move all 4 of those. Now, if you didn't circle it, don't move it. So the 36, the 4x cubed, the c to the fourth, all of that's going to stay. We're not going to move those. Now, I did circle the x in the numerator. So that x to the negative second comes down to the denominator. The negative 2 becomes a positive 2. The y cubed, the y to the negative third, is going to become a y cubed in the denominator. And then that c to the negative 7 comes down to the denominator. The negative 7 becomes a positive 7. And then finally, that y to the negative fifth, it was in the denominator. I'm going to move it up to the numerator, and the negative 5 becomes a positive 5. Once again, take it slow. It's easier, much easier, the more work you show, the slower you take it. Now, here's what gets kind of confusing is we're in this pattern of subtracting exponents, adding exponents, but this is really a division problem. So when you get to the numbers, this is 36 divided by 4, right? 36 divided by 4 is 9. Let's do the x's. Are the x's, you have an x cubed and an x squared, are they going to cancel out or are they going to combine? Because see on the same side, 2x cubed, x squared, 2nx to the fifth. What about the y's? Are the y's going to cancel or combine? They're going to cancel. Because see I have y's in the numerator and in the denominator? They're going to cancel out. So 3 of them are going to cancel out. 3 of those cancel out. So you have a y squared left in the numerator. And then what about the c's? Do they cancel or combine? They combine because they're all in the denominator. So c to the fourth, c to the seventh, add, we would get c to the 11th. Okay, what do you guys think so far? Not too bad if you take it slow. Okay. All right, let's mix in that second rule that we talked about today. So number 7 says 3x over y to the 4th power. Remember that second rule is just like the rule we talked about yesterday. If you're taking a power of a product, everything in the parentheses gets the exponent. It's the same thing here. Everything in the numerator gets the exponent. Everything in the denominator gets the exponent. Don't forget about the number. You have to take 3 to the 4th, x to the 4th, and y to the 4th. Everything gets the exponent. And the only thing you can do here, 3 to the 4th, 3 times 3 times 3 times 3, will give you 81 x to the 4th over y to the 4th. Now let me ask you something. Can I cancel out the x to the 4th and the y to the 4th? Why not? Yeah, they're different. That's an x, that's a y. I don't know what x is, I don't know what y is. I'm not going to cancel out because they're not the same number. Very good. Okay, what if I have something like this? What if I have negative 7x cubed over 5y to the 4th, all to the negative 2nd power. Okay, now these ones, as they get tougher, I promise you, the more work you show, the slower you take it, the easier it becomes. Here's what I like to do, kind of like we talked about yesterday, get rid of the parentheses first, which means everything in there gets to the negative 2nd power. Everything! Including the negative 7. It's going to be negative 7 to the negative 2nd power. Now, when I take x cubed to the negative 2nd power, that's a power of a power. That was Friday's rule. What do I do with the 3 and the negative 2? You multiply them. You multiply them, so that's going to be x to the negative 6th. You also have to take 5 to the negative 2nd power. And when you take y to the 4th to the negative 2nd power, that's the same thing. You're going to multiply 4 times negative 2 and get y to the negative 8. Once again, just personal preference. Negative exponents, not really that easy to think about. So for me, I'm going to fix the negative exponents next. So the negative 7 has a negative exponent, the x has a negative exponent, the 5 has a negative exponent, and the y has a negative exponent. Everything has a negative exponent. So really what you're going to do here, just flip your fraction over. So it's going to be 5 squared. The 5 doesn't change. The but the negative 2 becomes a positive 2. Y to the 8th. Now be careful here because when you take that negative 7, the 7 stays negative. It's still a negative 7. What changes is the 2. The negative 2 becomes a positive 2. And then it's going to be an x to the 6th. And then lastly here, 5 squared is 25. Y to the 8th. Negative 7 squared, negative 7 times negative 7 would be 49. X to the 6th would be your answer. Okay, just a couple more here. And these ones, I'll say it one more time. I promise you, the slower you take it, the more work you show, the easier they are. There's kind of a lot of steps. Okay? All right, in parentheses, 3x cubed y to the negative 4th over 15 x to the negative 2nd, y to the negative 2nd, all to the negative 2nd power. Okay, not the only way to do these, but my personal preference, let's get rid of those parentheses. That's what I'm going to do first, which means everything inside here gets raised to the negative 2nd power. So we've got 3 to the negative 2nd power. When I take x cubed to the negative 2nd power, what you're going to do here with all of these exponents, you're going to multiply them by negative 2. So it's going to be x to the negative 6, y to the negative 4 times negative 2, will give you a positive 8, over, we're going to take 15 to the negative 2nd, x to the negative 2 times negative 2 would give me a positive 4, and then y to the negative 2 times negative 2 would give me a positive 4 as well. Once again, my personal preference next, I'm going to get rid of these negative exponents. So the 3 has a negative exponent, the x has a negative exponent, the 15 has a negative exponent. Now, if you didn't circle it, if it doesn't have a negative exponent, you're not going to move it. So the y to the 8th, the x to the 4th, the y to the 4th, those don't move. They're going to stay where they're at. But the 3 comes down to the denominator. Negative 2 becomes a positive 2. The x to the negative 6 flips down to the denominator. Negative 6 becomes a positive 6. And from the denominator, that 15 comes up to the numerator. The negative 2 becomes a positive 2. And then last thing here, 15 squared is 225. In the denominator, 3 squared is 9. Now let's talk about the x's. Are these x's going to combine or cancel? Combine, because they're both in the denominator, right? If they're going to cancel, they'd have to be on opposite sides of the fraction bar. We have x to the 6th, x to the 4th. How many x's do you have? 10. Yeah. 6 of them and 4 of them. You're going to have 10 of them. Now, do the y's combine or cancel? Those are going to cancel, right? You have 4 in the denominator. Those 4 are going to cancel out. 4 of these cancel out, so how many are left? 4. And see how they're in the numerator? So it's going to be a y to the 4th in the numerator. Okay, last one. Number 10. All right, in parentheses, 2x to the negative 3rd, y to the negative 2nd, over negative 3, x to the 5th, y to the negative 5th, all to the negative 3rd power. Okay, personal preference. Get rid of the parentheses. Everything gets raised to the negative 3rd power. Now remember, when you're taking x to the negative 3rd to the negative 3rd power, or y to the negative 2nd to the negative 3rd power, you're going to be multiplying all of these exponents by negative 3. So we'll first take 2 to the negative 3rd power. We would get x to the negative 3 times a negative 3 would give me a positive 9. Y to the negative 2 times negative 3 would give me a positive 6. Over, I'm going to put that negative 3 in parentheses. It's going to be negative 3 to the negative 3rd power. It'll be x to the 5 times negative 3 would be negative 15. And then y to the negative 5 times negative 3 would give me a positive 15. Okay, for me next, I'm going to fix the negative exponents. So I have the 2, the negative 3, and then the x in the denominator. Now remember, if you didn't circle it, don't move it. The x to the 9th, the y to the 6th stay in the numerator. The y to the 15th stays in the denominator. The 2 from the numerator comes down to the denominator. The 2 doesn't change, but the negative 3 becomes positive 3. Now remember, when you take this negative 3 from the denominator, the base stays. That negative 3 stays a negative 3. The exponent changes from a negative 3 to a positive 3. And then the x to the 15th comes up to the numerator and becomes a positive 15. So last thing, negative 3 cubed, negative 3 times negative 3 times negative 3 will give me a negative 27. 2 cubed, 2 times 2 times 2 will give me 8. Okay, do the x's combine or cancel? They combine, so 15 plus 9 will give me x to the 24th. What about the y's? Do they combine or cancel? Cancel. So 15 minus 6 would be a y to the 9th. Where's the y to the 9th at? In the denominator, right? Because all of those cancel out. 6 of these cancel out. The 9 that are left over are in the denominator.